In 8.3, we're looking at solving exponential equations when your exponents have the same base. So we have here that our property of equality for exponential functions. Let b be greater than 0 and b can't equal 1. Then b to the x equals b to the y if and only if x equals y. So for example, if we have 3x equals 3 to the 5th, that would mean x equals 5. And if x equals 5, then 3 to the x equals 3 to the 5th. So, in other words, if we can make the bases equal or the same, then the exponents must also be equal. So, let's take a look at our first example. We're asked to solve 2 to the x power equals 8 to the 3rd power. So I have our list of steps over here that we'll use. And step 1, we want to make the bases the same. So because the 2 has x on it, we're going to keep it 2 to the x power equals, well, we want to make that 8 have a base of 2. But then we have to figure out, well, what can we raise to 2 so that it would give us 8? And that would be the 3rd power. But we already had this exponent of 3 there, so we have to keep it there. So once we have the same bases, 2 and 2, now we're going to look at just our exponents and we're going to set those equal to each other. So x equals 3 times 3, and then solve. In this case, we just have to multiply those 3. 3 times 3, 9. And then we can plug that back in and check. 2 to the 9th power equals 8 to the 3rd power. If you needed to use a calculator, we have 2 to the 9th, which is 512, and 8 cubed, which is also 512. So check, we are correct, x equals 9. All right, here's another one. Solve the equation. 3 to the 2x plus 3 power equals 3 to the 5x minus 9 power. So step 1, make your bases the same. Well, when I look, our bases are already both 3. So we're good. Step 2, set the exponents equal. So 2x plus 3 equals 5x minus 9. From here, solve. So I would move 2x by subtracting 2x. And I would move that 9 by adding 9. So we get 3 plus 9 is 12 equals 5 minus 2, 3x. Divide by 3. So we get 4 equals x. And then we'd want to check that by plugging that, whoops, so 4 equals x. So now we check that by plugging that back into our original equation. We had 3 to the 2, instead of x I'm putting 4, plus 3 equals 3 to the 5 times 4 minus 9. So this would give us 3, 2 times 4 is 8, plus 3, 11, equals 5 times 4 is 20, minus 9 is 11. Those are the same, so our answer is x equals 4. Okay. Solve the equation. 4 to the x equals 64 to the 3rd. Step 1, make your bases the same. In this case, they are not the same. So 4x equals 4. Now, if you're not sure what we need to raise 4 to, you could always trial and error in your calculator. Let's say 4 squared, 16, so not what we want. 4 cubed, 64, so that's what we need to raise 4 to. But don't forget you had that exponent of 3 already there. So then we've seen a problem similar to this already. X equals 3 times 3. So x equals 9. And then you'd plug that back in to check. 4 to the 9th equals 64 to the 3rd. 4 to the 9th is 262,144. 64 to the 3rd is also 262,144. So check x equals 9. One last example. Solve the equation 2x equals 9 to the 5x minus 4 power. So step 1, make your bases the same. These are currently not the same. So 3 to the 2x equals 3. Now, in order to get 9, we'd have to take 3 squared times, make sure you put what was already there in parentheses. So now we can set our exponents equal. 2x equals 2 times 5x minus 4. And then we can solve. 2x equals 10x minus 8. Gonna subtract 10x. So then we get negative 8x equals negative 8. Divide by negative 8. And we get x equals 1. And then don't forget to take a moment and check your answer. 3, 2 to the 1 power equals 9 to the 3 to the 2 times 1 power equals 9 to the 5 times 1 minus 4. So 3 squared equals 9. 5 times 1 is 1, minus 4 is 1. 3 squared is 9. 9 to the first is just 9. Check. Our answer, x equals 1, is correct. And that's how we solve when we have the same base.